One of the phenomena that's happened recently is that we've seen a lot of increased, I think, misuse of statistics. And one of the disadvantages of statistics is that they only tell you what your data say, but you can also choose which data you choose to look at and what types of statistics you choose to apply. And in some cases, you can make your data say things that may or may not be entirely accurate. So let's take a look at some issues in that area. So, and again, this could be accidental or it could be intentional. In some cases, you might have just picked an invalid statistic for the data type you have. So if you have ordinal data, maybe you picked an invalid statistic for that, or there might be some type of error in the unit of analysis. So maybe you were expecting them to be in one types of units or to have homogeneous units, and it turned out your data was in different units. But it's also possible to, this is a little more almost nefarious, but maybe not quite, and this is something you're going to see in the news all the time, is this confusion between correlation and causation. Sometimes they'll see, oh, well, there's some association between, the number of trees in your yard and the possibility of cancer, the probability of cancer. Well, that obviously could potentially be a correlation, although it'd be a weak one at best, I would assume. And then the causation is something that would need to be determined in a different setting. So that's an example. But it's also possible to just straight up lie, either with statistics or with visualizations. It's possible to make visualizations that also sort of line, you're intending to communicate something that is not necessarily true. So it is possible to misuse statistics to do these things, and we, of course, ethically should not do so. And again, Tuft has some good examples for us in his books. So he actually has a whole chapter dedicated to this concept, Chapter 2, Graphical Integrity, and really this is one of the core themes of that book, 2007. This is the visual display of quantitative information. But if we kind of zoom in here, for many people, the first word that comes to mind when they think about statistical charts, or in this case he means visualizations, is lie. They think, oh, this is just what these charts are meant to do. And he gives some good examples of this. These are a little bit dated, most of these from the 70s, but they do have some good information here. So here, you see, and it looks, oh, things are going pretty well here. Unfortunately, you notice that in this case, our number was actually negative. So this is kind of an interesting thing. And of course, the 0 point here is actually something like minus $4.2 million. So this is one of the issues that we're having, as we're using kind of a similar 0 across the board here, but we're sort of hiding this loss that we had in that year. Now, of course, if you look carefully at the numbers, you can see it, but that's something that you would otherwise miss. And then down below here, we've got the commission payments to travel agents. Maybe this is an industry document, and you note that the there seems to be this big decline here. Maybe this is the kind of the thesis of the article. Oh, well, this is a big problem. Well, what you're missing is that this is the first half of that year. We're only looking at the first half of a year, and that's why, of course, it should be smaller. In fact, if things continue, we're going to, we're more than halfway, I think. Well, maybe not quite for, just a little bit over half for that one. For each of these, we're more than halfway, and so we're going to see this number actually exceed. We're going to see continued growth in all of these areas. So this is something that we need to kind of be cautious of as we are generating graphics, that we don't generate graphics that misrepresent our data. And of course, lying with statistical charts is nothing new, as Tuft points out. Here's an image from actually 1786, I believe, by a gentleman named Playfair, so 1786. And the thing that he points out is that this image is one, it's taller than it is wide, which helps us to see this nice government spending on the increase. This is national debt of Britain during the Revolutionary War, which would be this little period kind of right in there. And so As you can see, of course, the debt is skyrocketing. It's just going through the roof, and we're in just a bunch of trouble here. So that's one thing. Now, the other thing that he didn't do is inflation. He did not take inflation into account in this image either. So we get sort of a little bit of lying with the numbers here to sort of really emphasize his point that, hey, we're spending way too much. And this Tufts sort of humorously points out is really kind of the first of this general class of image that just shows government spending on the rise, as it always is. And of course, so here we've got a similar picture. In this case, we're looking specifically at the interest, so the numbers are going to be lower. But in this case, he did adjust for inflation. And when he adjusted for inflation, the numbers sort of smooth out. And of course, in this case, again, we're sort of wider than we are tall. So that sort of makes this seem a little bit less crazy than the other image did as well. Now notice that we're looking at the same time period here, and we do see an increase. You know, it's still a sharp increase, but it's not nearly got the emotional impact that we had previously. And another thing that he did, of course, is leave us a lot of sort of breathing space here at the top, which helps this image to sort of lessen that impact. So these are just some things that we need to keep in mind. It's very easy to sort of display our data in a way that really puts our interest forward. And what Tufts points out is that our goal should be the accurate communication of the quantitative data, not necessarily aiming for emotional impact. We're not necessarily in this to write fiction literature. We're here to communicate and perform analyses. And why is all this important? Well, what are the consequences that you guys can think of to lying with statistics or to the misuse of statistics? So pause for just a moment and think about some of those things. Hopefully you're back, and beyond the obvious ethical implications, there's also the issue of trust. I think trust in the profession, in professional research. This is something that I think a lot of us are probably familiar with the anti-vaccine crowd. This is something that has become a phenomena where long-established medical procedures that have been shown to be relatively safe over in some cases over 100 years are now sort of being questioned by a group that really has very little interest in looking at data and more interest in looking at personalities and so forth. And so we kind of see some consequences. Well, some of that, I'm not going to attribute the whole thing, but I'm sure that some of that is sort of a response, if you will, to having so many statistics given to them over the years that ended up, not really being reflections of reality. So this is something that the trust in research is reduced every time that a statistical display or something like that is misused and sort of put forward in a way that is not entirely accurate. So this is one of the major consequences, at least from my perspective, of doing this, beyond the obvious ethical problems with putting forward data that is not entirely accurate. So this is some of the reasons that we need to avoid and be cautious as we look at the statistics that we apply in our projects.